Yeah, thank you, Cassidy. Hello, everyone. Today I'm going to show some audio processing functions in the Wolfram language. And we are going to see, I'm going to use merely one example on an audio recorded owl that I kind of found last year in Champaign during the Wolfram Tech conference. I was doing an evening walk, and I heard something that sounded like an owl, a bird, singing. So I recorded it, and that's the recording. And I think I will share with you like what the sound of a great hornet owl looks like. Let me see. All right, so I'm going to use through this session this audio file of owls and try to identify owls species. And yeah, so the first kind of built-in function that we are gonna see is AudioIdentify. I think I showed it already on Tuesday. So it's like image identify, but for audio files, it's gonna try to guess. So inside it runs a deep neural network, and it will try to guess. In this case, it guesses correctly that it's a bird. And if we can ask for other identifications.
Jofre, I think your screen is paused.
Oh, yeah, I see. Sorry for that. I forgot to press the play button. Apologize. So yeah, that was kind of the outline, and yeah. So as I was mentioning, for the AudioIdentify function, we can also specify the type of entities that we want to identify. In this case, we can constrain it to animals, but it does not recognize the species of the bird. So for this, we're gonna kind of use Classify for building up a classifier that we already saw this function on Tuesday. And at the end, I'm going to use a neural network to train a neural network to identify certain owl species. Another interesting function is the spectrogram, and it has several methods. In this case, since it was in the middle of the city of Champaign, my recording had like a background noise of traffic of cars nearby the football stadium. So one can use a high pass filter and low pass filter to get rid of the car background noise of the traffic. All right, so the first thing I did after like recording the owl was to go to iNaturalist and check for which owl species are the most observed in Illinois, in Champaign. And it seems that the great hornet owl and the barred owl are the most common observed on this area. So I think we already you're already familiar with the interpreter and species to get the entities of the species for great hornet owl and the barred owl, and there are already like some thumbnail images for both of them. So this is the great hornet owl, and this is the barred owl. Similarly, we can get the scientific names for those species. And once we have the scientific names, we can use iNaturalist search, which I introduced on Monday, for retrieving a data set on observations containing recordings, audio recordings from iNaturalist users. So this is for the barred owl. Strix varia is the scientific name as a first input. We could have been using the entity as well here. It works both with as a string or as an entity. And then I'm asking for quality grade observations, like research grade observations, and then observations that contain audio. This is an information message just mentioned that indicates that the number of observations with audios exceeds 200. So there are like, in this case, there are like a total of 483. But for this example, I'm gonna use only a few examples for each species. As you can see in the data set, there is like information on the geoposition, observation dates, as well as the URL for, let me see. In the next column, you should see the audio URL, not, yeah. The same. I'm gonna do the same for the great horned owl. The scientific name is Bobo virginianus. And for this, we have a bit less observations containing recordings, but it's going to be enough for the example. With these data sets, what I'm interested in the audio URL part. So once we get the list of audio URLs, I'm gonna just for some reason I'm using a MacBook, and it seems that my Mathematica version was working better with importing these M4A audio files. So since we had like many recordings for each species, in this case, in this line, what I'm doing is to extract the URLs containing M4A audios. And then what I'm gonna do next is to run this map on importing all the audios that have a duration that is less than 50 seconds, and ask for the first 25 recordings that met this condition, and I get the audio files. I just kind of copied here in the notebook, so you don't have to rerun this import these lines for importing the audios. So you might want to not store if the data set on audios was larger than in this case, like hundreds of audios. What you want to do is to export, or like to store the audio files in your local computer or in a server, and then work from there. Since I'm using only like 25 audios per each species, is not a problem to handle on this notebook. So once we have the audio files, we can create a list of examples. That's the audio file plus the class label for each audio. And what we can do is to have a first grasp on how it's going to be, if it's going to be a difficult task or an easy task. And we can use a feature space plot to kind of visualize this kind of the result of applying to these audio files the feature extractor from this particular neural network, which was trained on YouTube data. And you can see that more or less in this area, in the upper right area, the great horned owl is located. There is some mixture, but overall, it seems it's going to be a feasible task. So once we have this we need to generate the training set and a testing set, and for this, don't forget to use random sample on the examples, so they're not they're in a random order. The examples for both the species, great horned owl and the barred owl, and this is the first four examples on the training set. As a first try, we can use a Classify, as we saw last Tuesday, and check how well does it do the task. So Classify, for this case, we're going to use Classify on the training set, and then ask for the information. It seems it did a fairly good job, but 80% accuracy, it seems that using the confusion matrix plot, we can see that it got confused on certain barred owls that thought it was a great horned owl. And something for my particular recording from Champagne, it identifies correctly the species as the great horned owl. But if I'm using the filtered owl recording, it completely misses the identification. So it might be that there is some overfitting on this kind of Classify. So the next thing to do is to try a neural network. And for this, I'm going to show you how to do transfer learning. So this is using a pre-trained neural network model that was used for a different task, but related task. So in this case, I'm going to take the neural network for the audio identify, and using net model and specifying the neural network that we want. This one also is available on the Wolfram neural network repository. So is this one here, and you can get directly to your Mathematica notebook using a net model. And there are like two neural networks. One is smaller, and the other is a large one. Yeah, small and large, you can specify. For this transfer learning, what we're gonna do is to kind of from the main neural network to extract. We want to kind of, so the main neural network is this one, this large kind of multi-layer neural network, and what we are interested in on getting rid on the last 3 layers, which are the classifier with these 527 classes examples from AudioIdentify, which we are not interested, but we are interested in the feature extractor, which it's gonna, since in our case it's a similar task trying to identify different audio classes. So once we have the feature extractor, what we want is to build up a classifier using a linear layer with a linear layer with two classes, and in particular we are using our as a classes our two different owl species. I'm going to use the common names for them, the great horned owl and the barred owl. And then what we are going to do is to just use the feature extractor to pre-evaluate the net. So this is equivalent to freezing all the weights except for those in the new classifier net. And finally, using a net train, we can train that classifier on the training set, and it's pretty fast. I think I can run it here again, so you can see that it takes a few seconds. Since we are only training the last 3 layers, the classifier layers, and keeping the rest of the weights from the feature extractor frozen. So yeah, the final net for obtaining the final net, we're going to use a net join on the feature extractor and the trained classifier. And once we have it, we can already evaluate the neural network using classifier measurements on the testing set. And for this particular case, it got all the testing set right. So it did a good job. And I also checked that, for example, the filtered OWL, so that the modified audio file without the background noise was also identified correctly as the great hornet owl. Again, so transfer learning is a good method if you don't have a super large training set, so you don't need to retrain the whole neural network. And in most cases, you will find in the neural net repository some network that pre-trained network that can do the job pretty well. And for reference, that you might, I want to point you that there are like several examples on the website on machine learning for audio. You can check out some of the examples here, and as well there is an example for net encoders for audio if you're interested in other properties and other, maybe more in the audio spectrogram. You can use them in your neural networks as well. And finally, just to mention, since I was using only audio files from birds from iNaturalist, I want to show you that there's also other platforms. This one is from Cornell Lab, and they have tons of audio samples from all kinds of bird species. Shannon Canto is also another open platform with many 100,000 recordings of different wild bird species across the world. And finally, also to mention that there is the web audio search, which you can use to get sounds from all kinds of things, not just animal species. For this particular case, I was checking out if the web audio search was like getting me some owl sounds, but it seems I only got like the barred owl songs, not the great hornet. But it's interesting that you know that this function exists. And with this, I think I'm done for today, but we can, maybe there are some questions that I could answer.
Yes, we do have questions. So we have a few questions that are not exactly about the topics today. So we'll come to those in a little bit. But for today, we have a question from Calvin. I think it's at the beginning of the analysis, Jofre, where you have the entity bird. Mm-hmm. And then you are moving on to something called strict forms as a search term for iNaturalist.
Oh, yes.
And Calvin is asking, how did you make that jump? Like right there. If you go back again, I saw in your search bar on the iNaturalist screenshot, you have.
Oh yeah. So in like getting this. So this is a screenshot here, or what's the question?
So if you go up a little more, right there. So in the search bar, you have Strigiforms or something. I'm sorry if I'm pronouncing it all wrong.
Yeah,
Right next to observation,
the family of owls. So
family of owl. Right. So
that's kind of going to iNaturalist site, and I think maybe just putting owls, you will get the order of
too many.
forms. Yeah,
Okay.
and
So you're just narrowing down your search.
and then you can specify. Yeah, exactly.
Okay.
Illinois,
Okay.
kind of get the most common owls. I think I can change it to a grid, or yeah.
Okay. All right. And then Jürgen is asking, how can we use transfer learning
Mhm.
in the case of a neural network based on net graph? So I suppose you can use transfer learning for really any net model, right? Whether it uses a
Right.
net chain or a net graph.
That's right. It doesn't. So it can be a net graph or net chain. You can. I think there is some example on tomorrow. I will do an example on image classifier using
Mhm.
net graph and doing transfer learning as well for mushroom images or mushroom species.
Okay. Jofre, would you mind pulling up the tutorial we have on neural networks and
Yes.
maybe showing that a little bit to our users?
So it's might not be in the
In our
list.
documentation, right?
So I don't know if you refer to this one or the one for neural
There
networks
is a
alone.
tutorial too, so
Yes,
let's see.
this one. Yeah.
If
On
you click on tutorials on the top right of that page.
Yep. Right. This is a large overview tutorial with many subsections, and here you will find like multiple examples on neural networks, from a basic LeNet ones with MNIST data to more sophisticated task. And actually, it's there are like many functions that I was not covering, like net replace part or other ones that might be useful for your net surgery task.
So in the audio analysis section, is there something specifically that you would point out to our users that might be useful if they are just getting started?
I would say that maybe just try to rerun the example with other some species or other, and then expand from there. So
Okay.
kind of rerun your own experiments and transfer learning, and maybe then you can as well retrain the whole neural network. Depending, also depends on the task at hand, of course. Yeah, the tutorial for.
Thank you. There's another question from Calvin, and he's asking about comparing the performance of the classifiers once you did filter the audio. So this is he's referring to what we have at the end of your slide 3. So if you wouldn't mind pulling up your slide 3.
Yes. I think that's slide 4.
Or maybe 4.
I think.
So I suppose you had a model which just ran the unfiltered audio, and then you had another model running the filtered audio?
Oh yeah. So I did for both, for the classifier function, run both models, as well as for So for the classifier function, it did a pretty bad job at the filtered recording. So it seems that for some reason it's kind of it changes the prediction. I don't know why. It might be that there is some overfitting on this logistic regression. Yeah, but it's a simple classifier function for this case, and for the test set, it already kind of got confused with parrot owl and great horned owl.
It does have an accuracy of 0.8.
For the testing set, which is not really large, I was using 40 examples for the training set and 10 for the test set, which is
I
also
see.
not that large. It
Okay.
might be one if you reruns the random sample and uses the other training examples, it might change quite a lot. So
Right.
that's why it's important to use then transfer learning, because I'm not using a really large data set on hundreds or thousands of audio recordings.
Okay.
One thing that one could do is to get like a larger number of audio recordings. Of course, I could go one by one and cleaning them up. For example, some of them might contain only 1 second of the bird singing out of 15 seconds. That's something that it's also important to clean up the data. And as well, there are like some data augmentation techniques, which I was not covering, for kind of changing a bit the audio recording in time windows. And
Sure.
that
I
would be
suppose.
also it would be like a way to augment to increase the number of training examples that you have by just I think the documentation covers some of the data augmentation techniques. And once
Which
you have more,
documentation in particular
I
do
need
you
to,
remember?
I don't remember exactly, but I think
That's
there's
okay.
something on data
Okay.
augmentation.
So you do remember there's reference to the other techniques for data augmentation in the neural network tutorial examples.
Exactly.
You just passed over that in your slide. So you do use the low pass and the high pass filters for pre-processing the audio. And Jay is asking, why do you use low pass and high pass one after the other instead of band pass filter? And this is a
Yeah,
question from Jay.
that's completely arbitrary. I was just wanted to show that there are like many built-in functions
Filters.
for filtering audios, but
All right.
actually the one for this neural network I was directly using the owl, the original of sound was working fine, but yeah, it's up to you. I think
Okay.
you can do
You
it's
can
also
try a different way of pre-processing the audio.
yes.
Okay, and we have another question from Roger, and I think I've heard this question before as well. So we are suggesting transfer learning, right, as a way of applying neural net models, and not build the model from scratch. However, even for like things like net surgery, we have to have some idea of the layer, like which layer do we want to drop, or which layer do we want to retrain. So how Roger is asking, how did you know which layers you wanted to retrain, and or which layers corresponded really to feature extraction in the model you picked?
Right. In such deep neural network, typically the classifier layers are the last ones, and we have yeah the last three in particular. So that's a kind of these three here, and for the feature extractor, it might be well that we might kind of be able to exclude some of them, but it's better to just keep it as it was from the original one. Especially if the task was really related, like in this case for the AudioIdentify 500 classes. For the classifier, actually, I could use a different linear combination of these linear layers. The only important part is that the linear layer is 2 as the number of the classes I'm using. But I think on the documentation we have also an example using just a simple linear layer and a softmax layer without the dropout layer. So one could try different things as well for the classifier. I don't know if as well, for example, for the validation set, I was using 15%. One could try even a smaller percentage from the training set and different max training rounds. I would say, yeah, it's sometimes a lot of kind of trial and error.
Trial and error, right?
And then you will get a grasp on an intuition on how is it performing. But yes, typically you have to for like you don't need to learn to know all the details on these large kind of stacked layers of this deep neural network. Yeah.
So just as a summary, so most of the layers towards the beginning of the model is more to do with feature extraction, and the classification really is happening at the last few layers, or
exactly at the very end. Yeah.
At the very end. So for example, what in the model that you have right there on your screen right now, so can you point out exactly which layers are doing the classification?
So these last three here, yeah.
Reshape.
And the logistics Sigmund.
Logistics Sigmund is getting the decision, really making the decision, right?
Yes.
Okay. Okay. And is output just the decoder?
And here, yeah, there is the decoder as a vector size. So probably it's already like dropping out the decoder. I need to check that.
So we would have to set our own decoder, right? If we were going to use this model and our classes were different.
So since we are like, you need to specify kind of the type of net decoder that you have. Yeah, and specify the number of classes. Also important is that instead of having these 527 classes for this for this AudioIdentify, you need to change that into a linear layer of x, which is x is the number of classes that you will have. And then also, I think there is something that might help to. It's in the next layer. No, it's next slide.
Okay. Yeah, so I think we have a bunch of these transfer learning examples across documentation in your examples in your notebooks. So I think we'll have it, even if it is suggested that transfer learning is easier than just building your net from scratch, which is very true, but we will have to go through a few examples before I think we get a hang of how exactly to modify any existing model to suit our particular requirement for classification or regression using a neural net model. Okay, we have a few more questions. So Vitali is asking if it is possible to use spectrogram functions to analyze electrical noise from equipment. If you have any thoughts on that.
I would say yes, but I haven't tried ever yet.
Right.
But I would say that that sounds a task that could be implemented using neural networks, right?
Right. I don't have anything from the top of my head right now, but um, it sounds like something that is definitely someone would have tried. So even we would be in the same place as you. We would be digging through documentation and examples and community posts to find if somebody has tried this or is also thinking of trying this. Jay has another question about the audio that you've been using. Were they recorded in stereo or were there?
This was recorded with my iPhone. I have no idea. So what's the internal specifications of my microphone, but it was a low quality recording. So it's
Something very
the amazing.
basic, definitely not specialized equipment.
And inside the city, so there was like the traffic of the cars passing by.
Right, so the ambient noise as well.
Mhm.
Do you think there would be difference, but if you had like mono or multi-channel audio? I haven't
I
really.
think um, the 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 function audio for Wolfram already like processes a bit that part. So I think we can check that on documentation, but it it can import like run like multiple formats, but yeah, one have to be careful on that if they have multiple channels or. But if I'm saying now that it's handled automatically, I might be wrong. I have to check that.
Okay, so now we can go back since we don't have too many other questions about this particular topic you discussed today. We can go back to a question from James, and I think this is extending on his community post and your reply to it.
Right.
As to he's asking how you could navigate the GBIF website to get the link that you were talking about in the community post. So for the others, if you would check our community thread, Jofre and James have been discussing. He's working on this example of getting some information. I believe he was using iNaturalist, and then Jofre suggested GBIF would be a better place to search for the information. So they're talking about how he could get that information from GBIF. And Jofre, if you could show us that.
Right. So what I pointed out is if there are like so many observations or occurrences on that species, it's better to go directly to gbif.org and here search for the species that you're looking for. And yeah, I think the species was I think it was brown anole, but I don't remember the exact species name, but I think we can find in, let me see, brown anole. It was this one here. So yeah, it was this lizard species, and there are like 37,000 occurrences and 11 infra species. And the idea is that if you want to kind of download the data, you would be able to I think that's a different site I was seeing. Yeah, so on occurrences, then you get these kind of the results, and here you will need to log in. It's a free registration platform, and then it will download as a kind of a zip file containing all the data. I think there's a text file or a CSV file which contains all the metadata for all the occurrences. And that CSV file or text file is the one that you can, once you store it in your local machine, you can use Yeah, GBIF import function or even semantic import to import the data. So it is that once you have these occurrence text files from the website, you specify the folder or like a direction of that file and use a GBIF import to get the data. And from there, it will automatically interpret the geoposition of the occurrences as well as the date for the observations. And some other metadata like the institution, if it was from iNaturalist or some national museum or some university. I don't know if that would answer the James question. Yeah.
Sure. I hope he can try that out and do let us know on the community thread, and then we can take it from there. So for the others, we hope you are able to access the community forum and check out some of the posts there. And if you have any further questions about some of the stuff that we have covered this week, remember tomorrow we start a little earlier, and we will be happy to discuss some of the topics that we have covered in the past 4 days. So if you want to revisit something in particular, please do let us know.
As well, tomorrow I'm gonna show some neural networks for image classification. So if you have some question that was left unanswered today, then we can check it tomorrow as well. Yeah.
Right, and then we sort of have our nice finale with Jofre's demonstration of how you can build and deploy the neural net model to your phone. So I hope you enjoy that.
I don't have the Android version yet, but it's for iPhone only so far. I'm sorry for that.
I think that's what we have for today. Cassidy, over to you.
All right, awesome. As Abrita said, that survey that you see when we close the session, make sure that you're putting any questions, anything that you want to see covered tomorrow in there so that we can have that prepared and ready to go. We'll start 30 minutes before the hour, so about opening 15 minutes even earlier than we usually do. So make sure that you're here and ready with your questions.
I
Also,
forgot the poll question for today. Sorry. So there's like a couple of poll questions I was planning to share and I forgot about.
Oh yeah, that's fine. If you want to push those out, you can go ahead and do that, and I'll just cover the rest of this really quick, what I was gonna say. Make sure you're reviewing that quiz as well and bringing that to tomorrow's review session. We want to make sure and give you all the possibilities to go into that quiz and pass it to get your program completion. So, and Jofre, if you want to cover the poll question, go for it.
Right. So the first poll question was related to AudioIdentify. So for recorded audio X, which of the following returns what X is a recording of? So the right answer is just that AudioIdentify can handle directly the audio file. So there is no need for the spectrogram function to be used there. And the last poll question was the following. Let me share with you. So which of the following function can be used to modify an existing neural net? Yeah, I think I will share the results. So the right answer is net join, but you're right that actually nettrain is also like modifying certain weights of the neural network. So actually modifies a bit, but no, it doesn't modify the architecture itself, the layers. So yeah, for this case, net join was the right answer. And I think that's all for today. Cassidy.